Hello everyone, my name is Dr. Shivali Verma and I am taking engineering physics and application. Today we are discussing about the topic Heisenberg's theory of light and interference. So, uh, this is the first topic of our first unit. So, what is the Heisenberg wave theory for light? As we know that initially Newton's explained that light is may consist by the very tiny particles and they are traveling in a straight line, and these particles are different size and shape. But when the when Young's double slit experiment came, that time we have seen some new patterns of the light, which is consist due to which is consist due to the passing from the light by two slits. So these patterns are known as an interference pattern, and it cannot be explained by the Newton theory. Therefore, Huygens gave its a new theory. And according to that, he said that when a light traveled in the medium, then the particle of the medium start vibrating, and consequently a disturbance is created in the medium. And he suggests that there is some hypothetical medium, ether, in which these waves are travel, which the ether cannot be explained further, and this concept going to be a vanish, means the ether concept is going to be a vanish later on. He's with this diagram I can explain you how he said that. He said that whenever the light we can illuminating a candle, then the disturbance of light is start traveling in the atmosphere, and this disturbance are traveling in the form of waves, means they are making some crust and trough, and energy is vibrating from one point to the another point. Next point, he has suggested that this light disturbance travel in the form of wavefront. Now, what are these wavefront? All the points are known as a wavefront, which are vibrating in the same phase. Means that when light is traveling and we take some points at the same time, then we got they are vibrating on a same phase, and if we are joining them with the one imaginary line, and then we got a imaginary geometrical figure. This geometrical figure is known as a wavefront. So he suggested the light is travel in the form of wavefront, and wavefronts are those points on which all the points are vibrating in a same phase. Next, he suggested about the secondary wavelet. Now, what are these secondary wavelet? When we draw a wavefront, and we find each and every point of the wavefront is capable to generate new sources. So, each and every point of the wavefront which is vibrating on a same phase is known as a secondary wavelet. Okay, now how we generate a secondary wavefront with the help of this secondary wavelet? So, he suggested that if we draw a mm, if we draw a wavefront on each and every secondary wavelet, and after that we join them by a forward or join them by a common tangent in a forward direction, then we get a secondary wavefront. So as you see here in this diagram, that there are this is our say wavefront, and each and every point of the wavefront is behave like a secondary light source or new light source. And if we draw wavefront of each and every wavelet and draw a forward direction tangent which join this all secondary wavelets wavefront, then we got a new wavefront, and this wavefront is known as a secondary wavefront. Okay, next he suggested that there are three types of a wavefront. When light source is a point source, then the wavefront generated by the light source is known as a spherical wavefront. This is the 2D diagram, that's why it is looking like a circular, but actually it is looking like a ball. Also, the shape of the wavefront is spherical when the point source is a light source is a point. If a light source is a line source, then the generated wavefront is a spherical, cylindrical. And if the light source is at far away, it means that it is situated at a infinite distance from the observer. Then the shape of the wavefront is considered as a plane wavefront. Okay. So, next he said that about the light rays. What are the light rays? Because many times we are studied light rays, not about the light waves. So what are the light rays? Light rays are the imaginary line draw perpendicular to the wavefront, and it is showing the direction of the propagation of light. It mean in the this light here in this picture you have seen that these red color lines which are the perpendicular on the wavefront. This wavefront, these lines are depicting the direction. These lines are basically what they are showing. They are showing the direction of the propagation. So rays are nothing but they are the direction of propagation of the light according to Huygens theory. Huygens also state that the wave intensity is proportional to the square of amplitude, and its intensity is decreases as the distances is increases. Next, next things, because as we know that this theory is given to explain the interference. So how now we can explain interference with the help of this theory? So, what is first we have to know that what is the interference due to the two, what is when two or more than two waves are superimposed to each other, then their light intensity is redistributed, and this phenomena is known as a interference. And you know that there are two type of interference. One is the constructive interference, and another one is the destructive interference. So, just I have to explain first that what is the superimposition. After that, we can move towards the interference. So as we know that suppose there is a one particle and one wave is coming and striking to the star particle, then what happened? These waves are actually a disturbance. So this disturbance, when this disturbance collapse with this particles, then this particle is also going to be displaced somewhere because they transfer energy and momentum to this particle. Okay. Now suppose there are some other waves which is coming in this direction, and now it's strike to this particle. Then what happened? This particle is now displaced somewhere here. So the total displacement of this particle due to this wave 1, we can say that W1, or due to this second wave 2, is the vector sum of wave 1 and wave 2 amplitude. Okay, it means what I am saying. What is the superimposition? Superimposition is the basically a displacement. It is a one type of a displacement which is occurs due to the a vector addition of amplitude of two or more than two waves which are striking over that point. Okay. So superimposition, in the superimposition some particle or some energy is vary according to the vector sum of the amplitude of the superimposing waves. So what is now interference? So in the interference of the light, due to the displacement of this amplitude, the intensity is redistributed, intensity is changed, because as Huygens says that intensity is proportional to the square of amplitude. So whenever the amplitude is changes, intensity also changes. So due to the superimposition, intensity of the superimposed waves are redistributed, or we can say that the resultant wave intensity is redistributed, and this is known as a interference of the light. So there are two types of interference, as I said, that constructive interference and destructive interference. So in the constructive interference, the crust of a wave is superimposed on a crust of other wave, and trough of the wave is superimposed on a trough of other wave, and the resulting wave amplitude is rise due to this. But in destructive superimposition, the crust of the one wave is superimposed on the trough of the other wave, due to which intensity is going to be a low, and this is known as a destructive superimposition, sorry, destructive interference. So same thing I have defined in my this uh, over here. The intensity at the intensity at a point corresponding to the destructive interference must be a zero, while intensity at a point corresponding to constructive interference must be a maximum. Okay. Now I'm going to explain how we can identify the constructive interference and destructive interference. Constructive interference and destructive interference could be identified or calculated by their path difference. So, what is the path difference? Path difference is the difference in the distance traveled by the two light waves from their respective sources to a common point. It is a very simple definition that if two waves are traveling and they meet on the same point, then at that time, whatever their difference, their path difference, that is known as a simply path difference. Okay, suppose we can say that one wave is traveling from this point. One wave is traveling from this point to this common point A, and another one is traveling from here and reaches at A, which is the same common point. So there is a some part difference because C is near to the A and B is little bit far away from the A. So whatever the difference occur between these two waves, that is part difference occur between these two waves is generally known as a the part difference. Okay, so how this part, with the help of this part difference, we can know the constructive interference and destructive interference. So in your 12th class, you have already wrote about this thing, or already you have read about this thing that we can easily calculate the constructive interference and destructive interference with the help of part difference. So if the part difference between two waves, if you have seen in this if the path difference between two waves is equal to the n lambda, then we can say that the interference is constructive, and if it is equal to the 2n plus 1 lambda by 2, then it is a destructive. Now, what is n here? N is a natural number which can be 0, 1, 2, 3, 4, anyone, any value it can be adopted according to our path difference, and lambda is the wavelength of the interfering lights. Now, in our day-to-day life, why we are not able to see the interference pattern? Because there are two sources are there and lights are coming from these two sources, but we are not capable to see the interference pattern because we cannot see the somewhere intensity is high, somewhere our intensity is low. So there are some sustainable condition for the interference, means that the sources we or lines which are interfering, they have to be follow some conditions. So what are these conditions? The first condition is that these interfering sources must be a coherent, means that their phase difference must be a constant with respect to time and position. Okay. Second condition is two interfering waves, means that these waves, those waves which are interfering to each other, they are having a same wavelength and time period. Okay. Next thing which is important then is that these are the amplitude and intensity of interfering wave must be equal or nearly equal. Third point, the separation between the coherent source must be as small as possible. It means that the source must be a point source. And second condition, the source must be extremely small. It means that the sources must be a point source, and the distance between the source must be a very small, not they are very far away to each other. The next point, the distance between the two coherent source and the screen must be as large as possible. And last point, the interfering must be propagated along the same direction so that their vibrations are along a common line. So I think so. If two coherent sources are following, or two sources following this condition, then only we can see the interferent patterns. Otherwise, we cannot be see the sustainable interference pattern. So till here we are discussing about the wave theory and interference. In my next class, we will discuss about the formation of two coherent sources, and after that we can discuss about the Newton's ring and Micah's interferometer. So thank you everyone. We will meet in our next class.